So when we talk about cold plasma, we talk essentially about creating a very, very high electric charge and turning atmospheric air into radicals. So we are taking the covalent bonds of H and N and O, and we are breaking it apart, and then we are pushing it into water, and then and then it creates all this magic. It creates all these radicals in the water, and the one that is of particular interest is nitrate. Okay, but we also get hydrogen peroxide. We get all these different radicals. Some of them are very, very short-lived, but some of them are also quite long-lived. And the reason why we are interested in this technology is because at some point we need to figure out, we heard Professor Wang talk about how the world population is growing. Well, if you break that further down, what you're really telling us, Professor Wang, is that we are going to run out of fertilizer. Okay, because food security is really, to a wide extent, it's about minimizing our waste, but we need to do better with the food we have to minimize our waste. We need to do crop protection, but we also need to find fertilizer somehow. I will argue this is the future. This is the fertilizer of the future, and I will give you some examples of that, or show this to you here in a little bit. So essentially, what we are doing, we are creating this plasma activated water, which has a large set of unique characteristics, which I will not go into today. But we can use this to germinate seeds. We can treat seeds and have them grow faster. We can get them to germinate more uniformly, which means that we can, if we have large roboticized productions, we can much more easily handle them because they grow faster. We can grow them in greenhouses, get them out of those facilities more quickly, and therefore have them exposed for less amount of time to pests, to different kinds of pests, including diseases and insects. We can use the facilities we have, whether we are in an urban or in a rural environment. We can use them more effectively, and we can actually use that plasma activated water as a carrier for pesticides. So you and I are going to work together, hopefully, on a number of things, and some of it is going to include use of plasma activated water to boost. We have demonstrated that we can get better performance of organically certified pesticides that normally would not do well. If we use plasma activated water instead of normal water, we can actually boost their performance. So there's a lot of ways that we can do this, but what I really want to get to is the potential of PAW as a fertilizer, because if we look at the world consumption of nitrogen fertilizer, we're talking about something like 106 million tons. So this is a huge demand, and most of the nitrogen fertilizer is inorganic, it's synthetic, it's produced by a handful of countries that use a lot of fossil fuel. So this is a production that is inherently unsustainable. We need to change that, and we have a solution for that. If we can get renewable energy, either from wind or from solar, we can convert air into fertilizer, which is quite extraordinary, because if we look at the atmosphere and we calculate the amount of nitrogen there is in the atmosphere, there's about 4,000 trillion metric tons. So there's plenty of it. So it's ironic we are in need of nitrogen fertilizer, yet it's right here. It's right here. So in essence, if we sort of play with that for a little bit, we have enough for about 38 billion years of nitrogen in the atmosphere if we were to convert it all into fertilizer, so that's a rather sustainable solution, right? So that's what we're looking at here. We can actually do that. So here's an example. So these are tomato plants that were grown at the same time, okay? And so they were watered at the same time, and you can see we have two different PAWs, so two different plasma activated waters that were applied. You can see that the end result is a much bigger plant to the right than it is to the left. You can also, if you go a little bit further, you can actually see that those plants were in the same greenhouse, same soil, same variety, irrigated at the same time. You can see that this one is a little bit anemic. It probably didn't have quite enough fertilizer, but you can see what happened with this when it got about 42% of its water from PAW. You can see the difference. So this is something that is becoming very, very powerful. We are creating a consortium. We are working, there are companies that are developing this technology. But in the interest of students and in the interest of universities, I want to mention this as we are doing, of course we're writing papers about it, of course we are. And of course we are putting it into courses and whatnot, so educating, but we are also wanting to create careers. And I think Guizhou University, if they really want to be part of the future, they need to also include entrepreneurship and working with business school, working with industry partners and get them engaged, have them to fund some of the research we are doing. And also we need to facilitate the contact with businesses so that we can do the kind of research that they are interested in. And I see plasma activated water as a venue, a vehicle that can get young people very, very interested in sustainable crop production. So this is something we are very interested in.